Today, we continue to work on our tower blocks game. The end result should look something like this. This is a reminder of the game itself. We have blocks. We're trying to put them on top of the underlying block as perfectly as possible. We're trying to reach the high score, the speed increases, and so on. So right now, what we have going is this basic gameplay. Pretty much the game logic is already there, and we need to work on some niceties in terms of lighting, in terms of animations, and we currently don't have those cutoffs falling down, but that's the stuff that we're gonna work in the next episodes. Today's episode is all about animations of our text. That means the score, that means these overlays, which are pretty static right now. Once we reach the game over state, we're simply showing it without any kind of animations. And we would like to change it. So let's jump straight into it. And first thing that we would like to do is we would like to introduce animations to our game. Let's define new struct, call it animations, and the first animation that we're gonna work today on is going to be ScoreAnimation, which we'll name just as score. What is needed to animate the score itself? We're gonna pretty much rely on the scaling factor. Once the block is successfully placed, we will increase the font size or scale it of our score label, and then gradually revert it back to scale of 1. So to achieve that effect, we need to track the scale factor and duration, right, during which we are gonna apply this score animation. Let's jump into init game, and we can say that right now we have some animations. Let's default to something. Our score animation is as easy as we set duration to 0 and default scale to 1. Let's jump into DrawGameScore. DrawGameScore. This one. So right now, what we're doing is we're just displaying some built-in or static label. We aren't actually producing the score. So let's change that. Let's create some buffer, call it text. We are gonna use it to print our score. So %zu is for our size t score. So what is our score? Well, we are keeping track of our placed blocks inside game placed blocks, but the thing is that the first block is actually already placed. So to keep track of score, we need to subtract 1 from it. And next, we can say that we're actually dealing with the text. Let's run it, and yeah, once the block is placed, the score is updated. There is no animation yet, and we need to somehow apply it. First of all, let's try to up the font size, maybe something like this. Position horizontal is in the middle, and vertically we can put it somewhere closer to our tower. It will look something like this, right? Very noticeable, good looking. So let's start working on our animation, and it is as easy as saying that font size needs to be adjusted based on ScoreAnimation and the scale factor. By default, this is 1, so nothing really changes, right? We restart the game, everything continues to work as before. The thing is that we need to update our ScoreAnimation, and we can do that inside a new function. We call it UpdateScore. We grab game and we grab delta time. Let's also grab ScoreAnimation so that we don't need to type this huge thing out all the time. And then we need to update score only in case duration is greater than 0. Right? So by default it's 0, and once we place the block, we will set the duration to some value, like half a second or so, and animate the score itself. First of all, we need to say that duration needs to be reduced by delta time, right? And if this animation duration reaches 0, we need to reset the animation itself, meaning duration is 0 and scale is 1. So with these values set, there is actually no animation and the score is shown as usual. So we need to think what the scale here is like. And the scale is going to be, we're gonna linearly interpolate it between some value. This is the scaling value that we want to apply. This is our default 1, 0 based on some t. What is this t about? So first of all, we have our duration. So we can probably do it this way. Animation duration, we divide it by ScoreAnimation duration. Let's define this thingy here, constant float, let's say like half a second, as we discussed before. So the duration actually starts with this value and we reduce it up until 0 right here. So initially this value is 1 or really close to 1, and as time goes on it will move towards 0. But when we do the linear interpolation, we're actually interested in this value t to go from 0 to 1. That is why we need to subtract this value from 1. So again, as soon as the score needs some animation, right, this value will be close to 1, and if we subtract from 1, then t will be really close to 0, meaning we will grab this first parameter or some value really close to it. As time goes on, t decreases, it starts moving towards 0, and our linear interpolation will also start moving towards 1 for the scaling factor. So this Lerp is actually part of Ray math, right? So it tells you that we are calculating linear interpolation between two floats. So pretty much t is expected to be between 0 and 1 included. If it's 0, we pick the first value. If it's 1, we pick the second value. And if it's something between 0 and 1, we simply pick the value between the left and right side based on how far t is from left or right. Okay, so this is us updating the scale, but the game itself does not reflect that. Why? This is because we actually haven't set the duration and the scale when we place the block. Let's also extract the ScoreAnimation scale just in case, something like this. ScoreAnimation scale. Let's move these constants up. And then we have this nice method called placeBlock, where we're trying to identify how we have placed the block, whether it was a perfect overlay or not. And once the block is placed, we can tell that, hey, let's do the score animation. So we set duration to our 1 or half a second. We set it to default scale and let it be reduced, the scale of the font size. Let's see how that works. Yeah, the animation looks good, except that we might want to maybe make it quicker. So 1/5 of a second. Let's see. Right, so looking great so far. So this is all you need to make a basic animation for the text based on some scaling factor. So next thing is this overlay. Start game, and when we're done with the gameplay, this GameOver overlay. Right now we are simply displaying the text whenever we reach specific game stage, but we would like to introduce some animation. So the text, we would like to have some fading in, fading out. We would like the text to move like from top while it's like fading in, and when we are removing the label, then it moves to the top and fades out. To achieve that, we need to first introduce another animation struct. Let's name it OverlayAnimation overlay. Let's define a new structure for OverlayAnimation. In order to track this kind of animation, we need to first define the overlay type. This is an enum overlay type. We're currently working with only 2 overlays, so start game overlay and game overlay. Pretty much if we had more overlays, or they had some interaction between them, we would need to track the animation for each of them. But right now we keep track only of one, because we are pretty sure that start game and game over happen at different times, and we can simply keep track of which overlay we're currently working with. Next, let's define some fade state. So as I said, we would like to keep things fading in or fading out, or no fading. So once the label is shown fully, we set the state to no fading, so that it no longer tries to update any animation. And next to it, we need to have alpha, which is for transparency. When the label is fading in, we would start with alpha 0, so we don't see the label. As time goes on, alpha starts to grow towards 1, and finally it will be 1, and the label is fully shown. And we would need to keep track of Y offset. So as I said, we would like to label move from top to its position, and when it's fading in and when it's fading out, we would like to move it back to the top. Let's define some basic or default overlay animation. Our type is going to be start game. Our fade is fading in. Our alpha is initially 0 because we're fading in. And our offset is going to be overlay animation offset Y. Right? Yet another constant. Let's define it here, saying that not float, probably just int is enough. Something like let it travel for 50 pixels before it reaches its position. Again, everything compiles, but really nothing has been done with our labels yet. We have this nice method, DrawGameStart overlay. And then there is DrawOverlay. Let's move it up so that we see these two functions, and they are pretty much the same. Right, so we have some GameState check, then the title, and we draw it. So it would be nice to have a generic like DrawOverlay function, which can handle both GameStart and GameOver. To achieve that, it will need our game pointer. It will need probably const chart title. We will also have subtitle. Then we need what? We need title size, meaning font size, subtitle size, as we would like to draw title and subtitle in different font sizes. And then there's going to be title Y, meaning where the title is positioned. And there is going to be subtitle Y, where the subtitle is positioned. Next, we can grab this thing and see what we need to change. Title is given to us, so we can remove this, we can remove font size, we need this and this, right. So we need to calculate the width of our title. Title width is given some title size, and then we can also calculate subtitle width given its font size. Position, we can probably just include it right here. Screen width minus title width, right? And same can be applied to subtitle, but we need to draw subtitle here. So we're drawing our title in the middle of the screen horizontally. Then vertical positioning is our title Y. Our font size, it's title size. The color dark gray, and same should be applied to subtitle, subtitle Y, subtitle size, and probably change the font to something like gray. Game is currently unused, but most likely will be soon needed. Now that we have this nice generic DrawOverlay function, we can convert this thingy to use it. We can say DrawOverlay with our game. Okay, it needs to be const. Title is start game. Subtitle is something like click or press space. Size, something like 60/30, so that font size of our title is twice as big as its subtitle. And then the Y and subtitle Y. Let's do something like this. And for GameOver, this should be the same, except that we need to say GameOver in the subtitle to restart. Let's see what it does. So we have this nice looking title now. We can press the space to start. We are playing and we're showing GameOver. So these titles are now looking a little bit better than before, but there is still no animation, which we need to apply. So let's think. First of all, we have defined the default animation right here. Right, so when we run our game, it starts with an overlay animation saying that, okay, we're going to animate start game, we're going to fade in, and we need to constantly update the animation. So UpdateOverlay, let's define new function, we have game, we have delta time, and here we once again are gonna grab pointer to animation so that we don't need to write this thing out all the time. And we can check that if animation fade is actually fading in, we need to do some calculation. If animation fade is fading out, right? And the third one is no fading, which means that we don't really need to do anything. So initially we are fading in. What does it mean? It means that we need to set our alpha to delta time, probably times some fade speed. We can define some constant of how fast the fading happens. Fade speed, something like this, can be adjusted. Now, if alpha has reached value of 1, it means like we're done. We can then reset things. So alpha is 1, offset should be at that time 0, meaning that our label should have reached its position by the time alpha is 1. And we can say that, hey, there is no fading. So fading in, animation has completed. We end up with a situation when there is no fading and alpha and offset are set to correct values for that particular state. The thing is that we need to update not only alpha, but we need to update offset y as well here. And offset y is going to be yet another linear interpolation between the offset and 0 based on animation alpha. So again, with linear interpolation, we expect this value to be from 0 to 1. Luckily for us, fading in always starts with alpha being 0 and it grows towards value 1, which means that initially when alpha is 0, we're gonna pick this offset, which is -50. And as alpha grows towards 1, we are changing our value, which should shift towards 0. So it starts with -50, goes to -49, -48, and so on until it reaches 0. And interestingly enough, the code for fading out is almost the same, except when we are fading out, our alpha should be 1, right? We are showing the label and would like to fade it out. So we would like to start reducing it. The offset remains the same linear interpolation. So because alpha starts as 1, our offset is initially 0, and as alpha decreases towards 0, this linear interpolation is going to produce values which move towards this offset. So -1, -2, -2, up until it reaches -50. And then if alpha has reached 0, we can say, yeah, it's a 0, offset should end up at our offset y, and again we set fading to no fading. Let's try it, and the label is simply shown. Nothing happens, no animation. Why is that? And that is because we're not applying this animation when we are drawing the overlay, right? So that is why our game pointer is currently unused. So let's fix that. So to animate things, what do we need to do? First of all, we need to apply the alpha. Right? So let's say that we have color dark something and color light, which is going to be something. We will say that our title is drawn in dark color while subtitle is drawn in light. And we would like to use built-in Raylib fade, which tells us, okay, let's grab the dark gray and apply some alpha to it. And this alpha is going to be overlay alpha, which we calculate every frame. Same is applied to gray, overlay alpha. And this should already produce, fading in. But when we start the game, the label doesn't fade out, it simply disappears. Why is that? It happens because in our UpdateGameState, once the input is pressed, we do not change the animation property to fading out. So let's do just that. Animations overlay fade is actually fading out. Run it again. It's fading in. I'm pressing space, and no, it simply didn't work. Why didn't it work? Let's see. Fading out. All right, let's see how we update overlay. If fade is fading out, we need to start reducing the alpha. But that didn't happen, and it probably didn't happen because we are checking the state here, right, when we draw the overlay. But now we actually would like to draw an overlay regardless of the state we're in. We are more interested in what in game animations overlay type, right? So if our animations is currently dealing with start game animation, so if the type is not start game, then we don't have to do anything. Same should be applied for GameOver. So game animations overlay type isn't GameOver, then we don't do anything. Let's check it. It's fading in, we start the game, and it fades out. Really nice. Once we restart the game, the logic breaks. We need to adjust that, but before we jump to that, we need to also make the label move, right? So when we draw it to some position, we can also add to it our offset Y, which is also dynamic, and it goes from -50 to 0 when we are fading in, and from 0 to -50 when we are fading out. And it looks like this. We're starting the game and the label fades out. So next thing is UpdateGameState again. We need to now make some adjustments to these state changes so that our GameOver is shown correctly. So how do we do that? So initially when the game starts, we're fading in our start game overlay. Once the input is pressed, so that we're starting the game, we move into this playing state. We're saying, okay, overlay, start to fade out. It fades out. It is still in start game overlay, but it reaches alpha 0 and does nothing. We're playing, all is great, but then at some point we fail to place the block and end up in this else statement. Here we need to say that, hey, animations type is actually GameOver, and the fade is going to be fading in, right? So we failed to place the block. We're switching the type and fade to fading in of GameOver overlay. We can keep the alpha as it is at the current value when it happens. Should be 0, but if we like click really fast and end the game really quickly, it will just pick up the alpha from the start game overlay. But really, that in most cases is not an issue to be afraid of. Finally, when we are presented with an overlay, we can once again press some button and start the game again. So in this case, when I'm pressing the button, I would like my GameOver overlay to disappear. The thing is that we're calling init game here, which resets the whole animations structure right here. So we need to do a bit more work. Let's say that, yeah, we need to again tell it that this is going to be game over. We're going to be fading out. Our alpha is 1 and our offset y is 0. And once these things are in place, we can see that start game overlay is shown correctly. Then it is fading out. We're playing the game and suddenly make a bad move. Game over appeared and we would like to restart the game now, and it disappeared. Really nice. So this is how you achieve some basic text functionality, text animations in Raylib or really like wherever. Now, one thing I would like to adjust maybe is that when you have finished the game, we would like to still show the score so that you can remember like what score you had, because you might not be looking at it and tracking it during the gameplay. To do that, we need to adjust DrawGameScore function, which currently checks the state for playing state, saying that we are displaying the score only when we are playing state. And we really have only 3 states: ready, playing, and game over. So we can really say that, okay, if our state is ready state, so when the game hasn't started yet, hasn't even run once, then we don't show it, but otherwise always show it. So initial game start, the score is not shown. We are starting to play, everything is shown, then we make a mistake, the score remains, we might adjust a bit its position, right? But the game is over and I can relax and check my score counter that I might have not paid attention to while keeping track of the blocks during the gameplay. So the only thing here is maybe like 220. Yeah, I think it looks much better now. Alright, so this is pretty much it for today's episode. We have reviewed how we can do a few text-based animations, and what we're missing, or what our next steps are, is we need to work on our camera movement. So it is still like jumpy, it doesn't smoothly flow to the next block top position, it simply jumps there. We will fix that. Then we need to animate the cutoff blocks. So when we cut off some part of the block, of the moving block, we would like to animate it so that it drops down. And finally, we are currently drawing our cubes with wireframe, because otherwise there are like no shadows, there is no lighting. We will work on the lighting shaders, apply some basic lighting on our own. And maybe as an extra episode, we can work on some animation of the tower dying or collapsing once the game is over. But yeah, we'll see how it goes. Alright, so hopefully you enjoyed this episode. Please do like the video if you did. And if you haven't yet, please do subscribe to my channel. It helps me greatly. And I'll see you next time. Bye.